the Siberian Nuclear Research Center. Script and direction, Rosin. Camera, Homerkov. Consultation, Sidorov. Released by request of the USSR State Committee for the Utilization of Atomic Energy. Novosibirsk Documentary Film Studios. How quickly Siberia is changing. When a group of outstanding Soviet physicists first arrived here, there was no airport, no institute for them to work at. There was a laboratory of new accelerating methods at the Institute of Atomic Energy, which now bears the name of Kurchatov. The laboratory soon became too small, as the problems the research group were working on demanded powerful experimental equipment. The idea of moving the laboratory from Moscow to some town with a highly developed industrial culture became a pressing necessity. In 1957, when academician Lavrentiev took over the organization of the Siberian Department of the Academy of Sciences, Professor Budker and Professor Naumov headed one of the main institutes of this department, the Institute of Nuclear Physics. When man learns to control thermonuclear reactions, our planet will acquire, so to speak, a second sun behind this window. Attempts are being made to light up this second sun. This equipment is intended for research of plasma with relativistic electron temperatures of around 2 million degrees centigrade. Vadim Volosov has combined Professor Budker's old idea of the magnetic bottle with a new accelerating technique. This laboratory is concerned with overhot plasma of rarefied concentration. Overcold plasmas of alkali metals, potassium and cesium, are experimented with in Natalia Buchelnikova's laboratory. Her equipment serves the purpose of model testing the processes of plasma instability in the magnetic field. The equipment you see and the one placed after it has been constructed for experimenting on overcompact plasma. Explosions of this kind are used to model test magnetohydrodynamic processes occurring in compact plasma. The experiments are carried on in Alikhanov's laboratory. And so we have overhot, overcold, overcompact. But the thermonuclear researchers use the word over in still another case, when the subject is connected with plasma evolved by overfast processes. The idea of heating plasma with the help of shock waves was formulated by Sagdeev and put into practice by Nesterikhin on UN-type installations. This is one of the equipment, UN-3. The source of energy of the shock wave is a powerful condenser line. The data of high-precision instruments is registered by photographic equipment. Several stages of experimenting on plasma are worked out on an optical interferometer as well as with the help of laser. During the experiment, a preliminarily ionized plasma is injected into the magnetic mirror geometry. Then, a rapidly rising magnetic field generates the shock wave, which heats the plasma to 100 million degrees, and the plasma retained in the magnetic bottle is tested. In Yuri Nestorikhin's laboratory, more powerful equipment based on the same idea is today being installed. Viktor Galitsky, Spartak Belyaev, Roald Sagdeev. Along with these well-known theoreticians, many young people whose names may soon draw the attention of the physicist world are present at the seminar. This is Alex Galeyev. He is one of this year's graduates from the Novosibirsk State University. Nevertheless, he has already managed to put in a word into science. Training of young specialists is of major importance, and the scientists of the Siberian Department of the Academy of Sciences decide this problem collectively. Attached to the department is a special school, where the Olympic system is used to enroll the most capable children. Both here and at the Novosibirsk State University, the scientists are training their successors. At the Electrotechnical Institute, a special group has been organized, headed by Yevgeny Abramyan, a young scientist. He will open an unknown world to them so that practical observation and study will help them to fathom the mysteries of time and space. Until recently, the increase of energy of particles in the accelerators depended directly on the size of the machine. Present-day accelerators, therefore, have indeed become cyclopean, standing on the brink of reason and possibility. The Institute's scientists are searching for ways of increasing the energy while decreasing the size of the machine. One of them is Budkera's idea of a relativistic stabilized electron beam. This requires a 1,000-ampere current. Accelerator P3 is a pilot machine on the way to procuring a stabilized beam. It is designed for a current of several hundred ampere with an energy of 40 million electron volts. Research on the problem of injecting intense proton beams into the ring accelerator is carried on in Gennady Dimov's laboratory. These experiments are based on the principle of recharge injection. This is of vital importance for the program connected with research on non-iron proton accelerators, which Dr. Abramyan is carrying on in his laboratory. In non-iron magnets, the field may be increased from 10 to 20 times in strength, which means that the accelerator may be decreased from 10 to 20 times in size. Consequently, the magnet may be 1,000 times cheaper. However, all attempts to build an accelerator with a high field depend on a design of very rigid coils. And how big is the pressure? With a field of 150,000 Ørsted, the magnetic pressure is equal to approximately 1,000 atmospheres. Only an extreme, precise construction can put up resistance to such pressure. Budkera solved the problem by suggesting an original magnet design with a balanced central bar. That's how the operating model of accelerator CB looked. The non-iron accelerator in Samoilov's laboratory looks very simple. Its construction is based on two concentric cylinders with a lid made of organic glass. A big battery of capacitors serves as the source of a 1,000,000-ampere current. As it flows through the inner cylinder, it creates a powerful magnetic field. We'd like to mention a remark made by American physicists who visited the Institute last year. The whole world knows, they said, that the non-iron accelerators don't work. But Siberians don't know that. Ivan Samoilov is adjusting the accelerator. The energy of the electron has already reached 200 million electron volts. The non-iron accelerators do work. In the setup of colliding electron beams. 2 ring bands of this machine are designed for electron energy of 130 million electron volts each. Summed up, the 260 electron volts are equal to 70 billion electron volts of linear acceleron beam. This is still another way of increasing the energy of particle interaction. This is the way a beam of electrons is seen by the head of this laboratory, Alexander Skrinsky. We'll now show you how a sensitive apparatus sees it. The intensity of light radiation of revolving electrons decreases in leaps. The last leap corresponds to the death of the last electron. The flight path of dispersed electrons is observed with the help of spark chambers. A camera registers the observation. A new protected system of spark chambers is being set up in the laboratory. For the time being, it's adjusted to cosmic particles. Experimenting with colliding beams will help to check the correctness of quantum electrodynamics at distances in the order of 10 in the minus 14th degree centimeters. The experiments are carried on in Benjamin Siderov's laboratory. Possibilities for research will be greatly enriched when VEP2 installation will be operating at its full capacity. Different stages of the installation assembly have been photographed. The record speed at which this group of research workers carry on their work has become traditional. When B3M synchrotron was being assembled, Alexei Naumov and Vadim Panasyuk kept up a round-the-clock shift. The assembly work on the most complicated part of the storage apparatus was done in 40 days. The tempo of the vacuum group, headed by Dr. Blinov, is characteristic. It goes without saying that the vacuum level indicates the technical standard of the laboratory. The first vacuum of 10 in the minus 9th degree was reached while the Institute's premises were still being built. Everyone worked in the same tempo. VEP2 is in operation now. Its main assembly parts, the pulse linear accelerator, B3M synchrotron, and the one-band storage apparatus on which the electrons collide with their antiparticles, the positrons. VEP2 permits the increase of energy of the colliding particles up to 700 million electron volts, which corresponds to the energy of interaction of 2,000 billion electron volts. The machine gives the possibility of once again decreasing the distance at which quantum electrodynamics are studied, and also to elucidate many aspects of mu meson, pi meson, and k meson interaction processes. The Institute carries on a widespread correspondence. There's an increasing flow of letters from abroad. Novosibirsk, New Siberia, the young city revealing features of this Siberian newness. The physicists live in the newest district of the city, which is called Academic City. They plunge into their work with the same vigor. Every day at one and the same hour, members of the Scientific Council who only 10 or 12 years ago were at college take their places at the round table. The Institute community is young. Alexander Skrensky is 27, G.И.Будкера 45. He's looked upon as an elder. On the whole, they are all contemporaries of their young science, nuclear physics. Igor Kurchatov, a world-famous scientist and organizer, was the man who helped to bring up this young generation of scientists. And now, in distant Siberia, stands a monument to academician Kurchatov, a new center for nuclear research.